in listen-only mode.
Hello, this is Ellen Gunlack from Purdue University, and I'd like to welcome you to our Teaching and Learning Cause webinar today. I would like to give a special thank you to Lori Berghardt, who is the new person who organizes these webinars and who will be handling the technical details. She's taking over for Jean Scott. Today's cause webinar will be by Nicholas Horton, and he'll be talking about teaching precursors to data science in introductory and secondary courses in statistics. The way these webinars work is that we will all be muted except for Nick, and then if you have questions while Nick is talking, please type those questions into the question box, and then at the end of the webinar I'll be happy to ask those questions to Nick for you. So at this point, I would like to turn things over to Nick.
Well, thank you very much, Lori and Ellen, for putting this together into cause for, again, a great webinar series. You know, I've been thinking a lot, long and hard, about how to be bringing some of these concepts of data science into the curriculum, and I'm excited to talk about those today. There are resource materials, papers, and materials available at this website. Again, in 20 minutes, it's going to be hard for me to do more than just motivate some of these questions, but I'm hoping that those resources can be useful. And as you know, was just stated, questions for me can be submitted at any time. I want to begin by acknowledging some of my co-conspirators with the Mosaic Project, plus Hadley Wickham. And these are efforts to try to really bring computation into the curriculum and to weave together modeling, statistics, computation, and calculus. So my plan and outline for today is a somewhat ambitious one. I believe that students need this capacity to make sense of the staggering amount of information that's collected in our increasingly data-centered world. This is something we see all over the place. There's been this growth of what we call data science, and that's an important part of modern statistics. I'll talk about that in a few minutes. But I worry at times that our introductory and second statistics courses will often neglect this fact. So my goal today is to provide what I hope is a practical foundation, or at least motivate how that could be done for students to be able to compute with data. And for me, one of the definitions and the real foundations for this is provided by Nolan and Temple Lang in their 2010 American Statistician paper, which, though it really looked at the whole undergraduate and graduate curriculum, laid out a framework for computation and statistics. And if you're thinking about some newer approaches, Bill Finzer's paper on data habits of mind in K-12. So there's a lot of efforts here that try to think about how to be bringing in data science, data computation, thinking with data, and that's what I want to focus on today. So I think the goal needs to be to introduce students early and often, and I'll come back to that point a little bit later, to what are increasingly commonplace tools for data management, visualization, and reproducible analysis, and to really think about how to apply those to real-world scenarios. And I'll pick one example with the airline delays data set. Now, much of what I talk about today will just presume that you have a background in R Markdown or reproducible analysis. If not, there's a wonderful previously put together ECOT's cause webinar on that that Mina put together. There's some papers and other examples on the website I provided. But I think the Markdown approach of reproducible analysis helps to scaffold a lot of the things that I'm going to be talking about in a little bit more detail. I also want to kind of mention this idea that what's exciting now is not only do we have all these data, but the computational tools, I think, are orders of magnitude easier than what existed even 5 or 10 years ago. These new tools facilitate sophisticated data wrangling, modern analysis, and creative visualization in ways that are now accessible to a much broader group than what was previously require, months and months of programming to put together. So why are data-related skills so important? This oft-cited McKinsey & Company report stated by something like 3 years from now, so we're kind of getting closer to this, that the U.S. could face a shortage of hundreds of thousands of people with what they call deep analytical skills. And I think here the nomenclature is really important. We aren't talking about statistics per se, but statistical analysis is really at the core of what I think they're referring to in terms of deep analytical skills. They also talk about millions of managers and analysts with what they call the know-how to use the analysis of big data to make effective decisions. And for me, when I think about statistics, it's really thinking about this idea of using data to make decisions. Now, a large number of these workers will be at the bachelor's level. The pipelines are just not large enough in STEM overall to be thinking about, graduate level or doctoral work. And it's important to remember as well that most of these folks will not major in statistics. So how can we ensure that folks that might take 1, 2, or 3 STAT courses have the appropriate training to be able to at least engage, to be successful in this time when they really need to be able to make sense of the data around them? This shows up in lots of other areas. I won't belabor it too much. The Committee on the Undergraduate Program in Mathematics has put forward new recommendations for degrees in the mathematical sciences, minor and major programs. One of their recommendations talks about the importance of technological tools, this ability to be able to use technology effectively, that this use needs to incur with increasing sophistication throughout a major curriculum. To me, that implies that you need to be starting in the first course and then building more sophistication later on. That mathematical sciences majors, stats, math, applied math, and others should include concepts and methods from data analysis, computing, and mathematical modeling. This is what a modern mathematical sciences degree should look like. The ASA recently endorsed updated guidelines for undergraduate programs. And again, I think these go beyond majors and minors to thinking about second and third courses in statistics. They expect that these programs will provide sufficient background for students in the following core skill areas: statistical methods and theory, data manipulation, computation, mathematical foundations, and statistical practice. And so we really need to be thinking about these as kind of a framework for how we get students engaged. I mentioned previously this Bill Finzer's TIES paper, The Data Science Dilemma, looking at K-12 issues and how we can be building precursors there. Rob Carver has a wonderful paper from ICOTS from last summer where he argues that it's time to include data management in introductory statistics. I'm going to primarily talk about tools in R, but Rob talks about and motivates how this can be done in JUMP, and I think it could be, the technology is not as important as bringing in these concepts and get students wrestling earlier. Hadley Wickham's Tidy Data paper for me is very helpful because it provides a framework to be thinking about some of these questions. So what are the key skills that we need students to be able to do? I think effective statisticians at any level display this integrated combination of skills that are built upon statistical theory and concepts, the use of statistical applications, kind of working through different analyses, what we call data management or data manipulation, computation, and communication. And the same way that the CUPM described, we need the students to have this scaffolded exposure to develop connections between their statistical concepts and theory and their application to statistical practice. Students need to be able to think with data to be able to solve problems. So, if I look at kind of thinking about, when this happens and how it comes together, there's a lot of debate about what's meant by the term data science. And no matter what the definition, I think it's important for statisticians to be involved in all of these areas, from data process and how data are actually created and curated, thinking about visualization, data mining and machine learning, which are topics that are familiar to us, but it's not been necessarily a central part of our training, ideas of pattern recognition. The data science part to me is really the kind of the preparation part to kind of be thinking about using data to be able to get it in a form that we can then apply statistical methods and approaches. So what are the key changes? And I think the main one for me that I'm tracking is this growing importance of data science. And working with data requires extensive computing skills far beyond what we've traditionally taught. It's much broader than kind of just applying a two-sample t-test to a to kind of an existing data set that's at the back of the book. That students need proficiency with professional statistical analysis software, this ability to wrangle or access data in various ways, as well as the ability to utilize algorithmic problem solving. They need to be fluent in some higher level languages and talk about some facility with database systems. That's beyond what I think is really in the first couple courses, and it's certainly beyond what I can talk about in this webinar. But I think those are the areas that I think students need to be seeing, that statistics is part of those areas, those are the tools that statisticians use. Hadley has a lovely view of the data science process, and he's published this kind of idea of, this 3 steps, this data collection, the analysis, and communication. There's several things that I think are important here. One is that the idea of data collection is really important. Refining, deriving variables, that iterative process, data don't show up in the real world as a CSV file. So much of the work needs to be done there. We think in painting that 90% is preparation. I had a similar approach to data manipulation and management. That first collection, gather, tidy part is a big part of what we need to be doing. We tend to focus much of our efforts on the modeling part of this second part, where we essentially hand students some data and kind of a focused question of how they might be proceeding with that. And I think the real world now is becoming much more diffuse with thinking about what we might call exploratory data analysis in terms of visualization, to be thinking about, explanation, kind of communication, dissemination. We're moving much more beyond kind of static graphics to dynamic graphics. And I think this kind of data science, the iterative process of this, is really the scientific method as it applied to answering a statistical question. So for these data-related topics, students need to have some facility with professional statistical software environments. I think it's certainly possible and not unreasonable to teach a statistical literacy course where there's really very little technology involved. But the moment students start to work on projects, I think it's then important to be modeling professional tools and structures for them. Data analysis needs to be done in a well-documented and reproducible way. Again, these new tools, R Markdown in particular, allows that to be done in a much more streamlined, much less syntactically complicated manner. And at some level, students need to be able to manage and manipulate data. This includes joining data from different sources, restructuring data to a form that's suitable for analysis. These are all kind of approaches that allow them to be kind of thinking with data. So a case study that I wanted to introduce, and there's examples of this provided on the website that I listed at the beginning and then I'll come back to at the end, is coming from the airline delays. So, this is easy to motivate the students. If you ask them, have you ever been stuck in an airport because your flight was delayed or canceled and wondered if you could have predicted the delay if you had more data? And so the airline delays data set can enter in one of 2 ways. Today I'm going to talk about the second example, what I call small data. But the first one is to actually utilize all 180 million flights since 1987. And again, this requires a database. It's a different webinar to talk about how to do that, but we give examples of this on the resources. I call this medium data. It fits just fine on my computer. It took me a couple hours to get it set up, and it was mostly downloading these files from the government database where these are available. But once we have that, it's not big data that requires kind of very complicated computing to do. It's straightforward to do it, just not using a kind of a workflow where you load it all up at once. Again, that's not something I'm going to be talking about right now. I'm going to be describing what you can do with this New York City Flight 13 package in R, which is 300,000 odd flights. Again, this is still considerably larger than most textbook examples, but it's used in our courses in various ways without too much difficulty. What's nice about this, it actually includes 5 data sets. The list of airlines, all the information on the airlines, similar information about airports, the 300,000 odd flights that are linked in that, a data set of planes, and also weather on an every 15-minute basis in New York City during that year. So that actually allows students to be thinking about a couple of key verbs or idioms. I don't know how you want to describe them. Again, Hadley Wickham has provided a nice structure to be thinking about these data manipulation, management, or wrangling tools. The approach we've taken in a lot of our work with Project Mosaic is to develop a small set of commands, in this case verbs, that can actually do some fairly powerful things and connect them in some fashion. Again, similar structures are available in other environments. Rob Carver's paper talks about doing this in JUMP. SAS, other environments. What's important, I think, is to have a framework for teaching to be able to make this all work. Here, select allows you to select variables, filter, subset observations, mutate allows us to bring in, derive new variables, summarize and group by allow us to aggregate, reduce things to a single row. Then we can actually start to try to make sense to tell a story from these data. We need to be able to think about merging objects, so left join. Distinct allows us to remove duplicate entries. Again, relatively small set of commands that allow us to do some powerful things. Let me give kind of an example how this might work. So here is a plot of the average delay by day and carrier of flights to Minneapolis-St. Paul from New York City airports in January 2013. We can see this density plot that comes together from these, from the average delay. We see that most flights are kind of, the average delay is on time for those carriers. They may have like 2 flights per day. They may have 10 flights a day. There's some interesting things going on. We want to kind of immediately look to see what happened with the multiple hour delays on average on one particular day. But again, we can kind of be looking for that and it kind of just starting some simple exploration. I might want to now look what's going on carrier by carrier, to see what's happening and to kind of break that down and think about, say, overlapping density plots. All that is put together using these 5 idioms. Now, I want you to take a breath a little bit. There's code, there's some syntax here. But what we've found as we've introduced this into our curriculum at Amherst and elsewhere in other kind of approaches and other environments is that people can actually pick up some of these idioms and start to make use of them fairly easily. Here we're taking the flights data set and going ahead and selecting the 7 variables that we care about and then filtering out so we only have Minneapolis and January. And then doing this combination of group by and summarize by grouping on the year, month, day, and carrier and calculating the average delay and the number of flights. And that actually gives us these daily averages by carrier, by airline, for the month of January of flights to Minneapolis-St. Paul. So we've kind of brought things down to a much smaller, more manageable number to allow us to focus on a particular question of interest. The next thing we do is to go ahead and merge the delays in with the airlines to get a better descriptive name rather than just a 2 or 3 letter code. These are put together in a relatively straightforward way. There's a data wrangling cheat sheet that describes these idioms in certain detail that provides just the front and the back pretty much all that you need to do some very interesting types of manipulations. This isn't rocket science. It is something that can be brought into the curriculum using these freely available tools. We can kind of think about a more complicated question. We have wind information about this. We have precipitation. I've given the code for this online and the examples. It doesn't really seem like it's the wind that's the problem. It seems like the precipitation. If we look at the light blue line, it's the days where there's actually precipitation of some sort at the New York City airports. And the dark blue line, there's not. We can see that there's an average delay that gets up to about 15 minutes. And it seems that the wind tends to be more on the days when there's precipitation, but the precipitation seems to be more of the associated, it was more associated with delays than the wind. There are lots of other questions that kind of jump out with this that you can actually explore with the New York City flights data, or for those with more interest and to try to bring in some of these other data by using a database. We can actually trace individual airplanes to see where they're flying in and out. Students can assess the impact of weather events on flight delays by merging in these weather data. We can actually see the effects of cascading delays through hub airports. We can assess time of day, day of week, and holiday effects. Here, again, there's less of a need for p-values and models than the need to smooth and visualize, to tell a story, to be able to use these data to be able to make sense of the world around them. So to be relevant in the era of data science, I argue that we need to have our students able to think creatively about data. They need to be able to tidy data and not just take things that are already pre-processed for them in some fashion. They need to be able to wrestle with data sets of varying sizes, some that are large, messy, complex, more challenging, less challenging. But to kind of make this give them repeated practice at posing a statistical question, finding data to try to answer that, and then modeling and then interpreting what they find. This needs to be built on an ethos of reproducibility. There's lots of issues in terms of what we call the reproducibility crisis. Kind of a necessary but not sufficient component of that is making sure that we can actually reproduce the particular analysis that's being done. Markdown allows this to happen because we can actually scaffold a lot of things in those markdown files we provide students to allow them to do much more complicated things than if they had to type all these commands and do all these things. How to make it happen? I think that we can introduce a small but powerful set of tools, and that makes it much more feasible. Again, there's caveats in thinking about any of these questions. As I said, this isn't just an R thing. It can be done in JUMP. Rob's paper gives some examples of that. Other systems can be done. I think what's really most important is to lay out the framework to teach a foundation of data manipulation and management. This does require additional learning outcomes. There's clearly aspects of it that are new, that are not as much part of our curricula for the ending of our first course or in our second courses. It requires a large degree of faculty development. We need more examples and sample activities. We really need to determine what to do less of. And again, that's not an issue I think we're going to solve today. My goal was to really motivate why we need to be thinking about bringing these things into the curriculum. So the key recommendation and my main question is, if we're not doing this now, when is it supposed to happen? Most students take only 1 or 2 courses in statistics. And if they don't see that then they see that statistics is not part of this data science world. And that, to me, is a major concern. We need students to be able to think with data, as Diane Lambert has said. They do need these multiple opportunities to analyze messy data using and modeling modern statistical practices. We need to introduce these ideas of design and confounding early, along with their theory, practice, and computation. It can't wait to the end of their program for a capstone or other kinds of things. Again, if we don't include this as part of our first and second courses, the vast majority of our students will not see these topics at all. And if we don't teach these things, others will. And I think that's a challenge for us as a profession. So thank you very much. I'm really appreciative of the opportunity to talk. I look forward to your questions. Just a reminder, there are resources and examples found at the following website. And thanks again for the opportunity to present.
Thanks, Nick. We do have some questions rolling in. I'm going to start with one from Janet, who asks, do you see data science as a separate course or as a set of skills to incorporate into early statistics courses?
So I really think both are true. I think that there's great potential for a standalone data science course. My colleague Ben Baumer from Smith College has been teaching that. There's a number of folks, the very innovative statistical computing classes at UC Berkeley and Davis, and I think dozens of others that are now coming online, where there's really a kind of a focused kind of preparation on these data science topics. But I think those courses are going to also need to be complemented by courses that start to bring these topics into the more general curriculum. A single course isn't going to solve this problem. There needs to be that repeated exposure. So again, I think most institutions are going to want to be thinking about ways of doing things in tweaking their existing courses as well as adding some courses to the curriculum.
Are you at all concerned that we're going to start losing a lot of statistics majors who will take these big data analysis courses and then just go that direction without following through on the major? They'll see all these jobs that are available?
Yeah. If you look at where where courses are showing up in areas of machine learning, of data science, and like big data, I think these are being taught in many places on our campuses. And oftentimes there are a lot that are happening amongst our colleagues in computer science. My concern is if we don't engage with that, that is where they'll be learning these things. And I think that there's a loss there. I think there's a lot that as statisticians we can bring to bear. Questions about design, questions about confounding that I talked about, questions about data quality, assessment of models. I think there's a lot of things where we need to be asserting that we do have a role, that we do have value. and that we want to then partner with these folks to ensure that the students coming out of these programs have an appropriate background to be able to help answer those statistical questions. I think in the past, computer science has not had much in the way of statistical topics. If you look at the guidelines for undergraduate programs in computer science, there's really very little statistics outside of computer-human interaction studies. And so I think it's important for us to really be engaging with them to make sure that the students who are taking these courses, some of which are appropriate in computer science, have an appropriate statistical background.
Okay. Janet is looking for a textbook recommendation because she said that Gelman and Hill's textbook requires some amount of data processing and defining variables, which is a step I found that students need to work with. Are you aware of any other textbooks where problems require students to process data prior to analyzing it for problems?
So I think that's an area where there's some things that are coming out now, that some are out, but we need many more examples for our students and also for faculty. I know that Nolan and Temple Lang have a book coming out soon that are kind of case studies in data science, and I think those will provide some good examples. And I know others are working on some of these approaches. The Getting and Cleaning Data course as part of Coursera that the Hopkins folks have included in their data science specialization can be pretty valuable. I've been working on some projects along those same kind of lines. What's exciting is I think there's a lot of resources that are now available, much of it free, some of it available through textbooks or for a fee, that really do make it a lot of much easier to be proceeding.
When you're starting out on the first day, how do you define big data to your students?
So for me, big data is a little bit of a misnomer. There's this wonderful quote from one of the head analysts at Goldman Sachs that talk about something like 90% of all data that have been collected the last 2 years. And we're thinking about kind of a scale of data when we talk about big data that's far beyond what we're doing in terms of our curriculum. What I think is important for students to be thinking is these precursors to data science. And that is maybe less the kind of focus on big data, but to be thinking about more messy or complex data. So this hype around big data and whether or not that's, I think most of us don't do big data. There's very little problems I can imagine that, I can't fit on my computer, which to me has been a working definition of big data. But we need to be getting students to the point where they can engage with some of those questions later on. But, there's a very funny Tableau video on medium data. And I think there's a lot of work to be done on small or medium data sets to be able to, work through those and to give our students the capability to be doing that. The ASA Data Fest, which was originally put together by Rob Gould and colleagues at UCLA, is now taking place at a dozen sites all over the country, isn't big data, but it gives students, undergraduate students, a weekend to wrestle with a large data set, a couple of gigabytes, and to really try to make sense of it. And again, that's not really talking about big data, but it's beyond what we're typically teaching. So I guess I don't tend to do as much big data focused discussions in my class because realistically I'm not doing big data.
You also mentioned that short of data analysis, you could work with these same ideas in a statistical literacy course. How would you recommend doing that?
So I think in thinking about a statistical literacy course, bringing up issues of ethics and application reading papers, trying to make sense of the questions that are being asked and how they actually come together, I think can make for a very compelling course. There's so many great examples. My students in my modeling intro course ended up picking a blog entry that was statistics or computationally related, and to kind of talk through just for 90 seconds about what was interesting to them about that and what they found. And I think that brought a whole series of interesting questions like the Facebook studies or kind of understanding kind of comparisons of NFL football players and sexual assault. There's lots of interesting questions out there that can be brought into a literacy course.
Okay. We've had a couple comments come in. Bridget said that statistics courses should not teach the how of big data techniques, but the why statistical concepts are needed to avoid errors in learning from big data. And Jean said that it would seem like this is an opportunity to work with external entities to work on real-world problems, authentic work and learning.
One real quick comment, if I could there. Dick DeVoe, as part of an ASA presidential initiative, is working to be bringing in some interesting stories and data sets that, that really do model some of these data science topics. And similarly, the Journal of Statistics Education Data Sets and Stories Department has been publishing more and more of these kind of messier, more complicated data sets. I think that's important for us to be creating, curating, and sharing.
All right, last chance for questions. Remember to type your questions in the box if you have any. Nick, how long have you been teaching these topics to your students?
So we've been really thinking for the last 3 or 4 years much more seriously, and I think it was spurred by both the paper by Nolan and Temple Lang and some of their follow-up workshops that demonstrated that it is possible to be bringing these things that were typically taught at the end of a master's program can be brought into a STAT program at the undergraduate level, and then start to filter down to, so we're starting to really see bigger questions and bigger data. Rob Gould's paper in the International Statistical Review on Statistics in the Modern Student really challenged us in that regard, and I've been trying to respond to that challenge by bringing in these questions early and often.
All right, thank you. I think that we've gone through everybody's questions. This was a fascinating topic, and I think we're all ready to go consider these issues for our own courses. Thank you very much, Nick, for your presentation and your great ideas. And I'd like to let everybody know that when you leave the webinar, there should be a brief survey for you to fill out that will give Nick feedback on this topic, or to give cause feedback on the webinar itself. I'd also like to let you know the next webinar from CAUSE will be on Tuesday, March 10th at 2 p.m. It's another teaching and learning webinar, and the topic will be Statistics in Society, Updating the Curriculum of an Introductory Statistical Literacy course for the Modern Student. And one of the topics involved there will be incorporating big data into a statistical literacy course. And then on the 18th, there will be a Journal of Statistics Education webinar. So thank you very much for attending and for asking great questions. Thank you to Nick for this presentation, and we hope that we'll hear from you all soon.